All right, well, hello, everybody. We're going to go ahead and delve into Chapter 3 today, and we will do some demonstration of one of the objects that they discuss in here. I believe it's the rectangle object. And we're going to be also continuing our talk about objects in general, and with the example of the string object. So a lot about passing, classes, of course, is a big part of this chapter. Passing arguments, fields and methods. Constructors is also a big component of objects and object-oriented programming. And we will look into other things as they progress through the PowerPoints and with demonstration. So when we think about what an object is, a lot of individuals, they first initially have kind of a hard time learning what an object is. And in other programming languages, you don't really start with objects. Chapter 3 is usually the if statements, all about if statements and making decisions. What's nice about learning Java is you're thrust into an object-oriented language where everything's an object. There's no way that you can even start the discussion of anything until you talk about objects. So it's kind of a nice change of pace for me in some ways. So when you think about an object, when I think of an object, you're defining the data type. So you can think of it as you are defining what this data type is and what it holds and how. And when I say what it holds, what information does it hold? And that information is always a number. Computer science, all computers, everything is just a number. It's to the different types of numbers, yes, we talked about that in our previous video. But when we put numbers in an object, we can do it with it can be a design, and the numbers make sense for that particular object itself. And not only that, but we have the ability to act upon those numbers with functions. So before we were just, it was just building functions that act on these primitive data types, and nothing was encapsulated. There was no nice box where everything kind of fit together, where we had an object that had numbers that made sense for what that object was, and then of course functions that could act upon those variables or those primitive data types, or numbers. Integers, doubles, floats, and whatnot. So that's when we think about when we say attributes are the numbers. The methods are the functions that act upon those attributes. And then once you define what the object is and what it holds, then you can have more than one instantiation of that particular object. So think of it like a cookie cutter. You make the cookie cutter, and it's a snowman cookie cutter. The eyes, the ears, the nose are the numbers, the arms are the functions or the methods, and then you can have more than one cookie made from that cookie cutter or that pattern. So part of that cookie cutter is the ability to store data, and then of course to perform operations on that data. So numbers, and then what do we want to do with those numbers? Well, we want to protect them, number one. So we have ways to protect that information, and then we want to have functions that are able to process those numbers, to act upon those numbers. And one of the objects that you guys use right off the bat is called a string. And so when we think about a string is a character or contiguous array of single ASCII code characters. And it also has functions that can act upon those characters. And then, of course, it has functions that report back or gives you the ability of how many, like say, how many characters are in the string that you create. When we think about strings as objects, you will have a name that references the object, and then you have what's inside the object. So right here, city name is, we're declaring a string called city name. City name is the reference. It references or it points to the data that holds the information that it contains. And it contains more than just this value Charleston. It also contains a number called length. So you know how many characters are in that string that you've assigned to city name. So we call, and Java and the other kind of, the other languages that are like C# and Java are pretty much the same thing. The intermediate language that's interpreted loosely. But essentially, they all work with pointers. And when I say a reference, I'm saying it is a pointer. These languages like Java and C# has made it so that you don't really see them as pointers, as references. You work with them normally like you would any other variable in some of the other languages that are kind of pointer centric, like C++. So you don't really, you work with them. They're much easier to work with as references in these languages. And so they reference the data that the object holds and all the variables and the functions that go with that object. And so that reference is done through an address. So city name is an address. It holds the address that kind of references the box that holds the city name. So let me give you kind of an idea of that reference. And the thing is, you know, this, even showing you this is not kind of helpful, because the language is taking so much out of this that you don't really see it as a reference anymore. You don't really see it as a pointer. You just see it as just another variable called city name. So but you have to have the knowledge that it is actually a reference. So when we think about a reference and city name, okay, come on, what are you doing here? Okay, there we go. All right. So let's say we have our reference city name. What that actually is it's just a variable. It's 4 bytes. It's a pointer. It's 4 bytes. It's somewhere on the stack in your memory, in your RAM. Say it's at address 2000 to 2004. And I'm just making up this number. This is all handled by the interpreter and the compiler and all that stuff. And then let's say that we have our box that represents the city name, and in it you have your characters, Charleston or whatever, Charleston, and I'm going to misspell it because I don't really care, Charleston, and then let's say that also has a number in it called length. And how long is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Length is equal to 11. So this is the box that represents the data of Charleston, and it has an address. Whoops, I don't know what I just did there, but that was interesting. But anyways, looks like I'm going to have to redo a lot of this stuff. All right, yeah, epic fail already today. All right, let's redo our drawing here. Okay, so here's our box, and it has length in it. It has the array characters, the characters of Charleston. Characters, I'm going to misspell that too. But what it does is it has a specific address that represents the first byte of that block of data. And let's say that that is at address 2004. And let's say that the size of this object, the string, is 100 bytes. So then that means that it will go from 2004 to 2104. And then our reference, which is city name, is the pointer. And the pointer is just a 4-byte number. Let's say that it exists at address 2000 to 2003, which is 4 bytes. And then up here, it's going to have address 2004, and it's going to say to point, and it points to that reference that actually contains the object, the memory of your object, in RAM. And so that's why we call it a reference, because city name itself is just a 4-byte number that points to the actual object itself. But you see, all this stuff, you don't even have to worry in your head in it, because the languages of C# and Java, they take all that out of you don't need to think of it that way, because it takes out the idea of it being a pointer. And you don't see it that way. It takes that out of your need to deal with, and that's also very helpful with an object-oriented language. Everything is a reference to an object, and it's all implicit within the language. Okay, so strings as objects. Here is where we would create a string, and we would call it, it's called city name. But here is where we can create a variable that's called the length of the string, and the object that we have, if we want to know how large that string is, we can access a property of that object called length. Now this is what we call a method, and it's a function that runs that will go in and it'll count all the characters inside of city name, all the characters that make up city name, Charlotte, all those Charlotte characters, and return that value that is the length of the string, and so you know how long the city name is. And you notice the parentheses here, and that's because it is a method. We don't really want to do this as, it's better to do some things as a method than it is to have a variable, because if it's a method, city name, its character length can change. So we don't want it to be a variable called length inside of city name, because it can change. So it's going to have to be something that acts upon it. So that's why it's a function. And this is a good portion that talks a little bit about the cookie cutter type of the thing of what a object is. You can think of an object that you're creating, an object as a blueprint of a house. And then if you go down and you look at a specific block, you see the same kind of house, but this is for address 1. This is or whatever address it is, address 1, and then this is another house on the same street, but it's the same type of house, but it is not the same house. So it'll be at address 2 on Broadway Street or whatever. So this will be 1 Broadway Street, 2 Broadway Street, 3 Broadway Street. They're all the same blueprint. They're all the same data type, but they're all the same data type, as in you define the data type, but they're not the same data. They're not the same house. The house comes from that blueprint. So you can have strings, multiple strings. They're all strings, but they don't all hold the same information. So here's an example of kind of that principle. String person, string pet, string favorite color. Now notice that we're assigning it to Jenny. So these are all strings, and we give them all their own name, their own address, or not the address. Well, I don't want to confuse address with the reference types. We all give them their own name, but they're still strings, but they have different names and they hold different amounts of data. So you can think of, this blueprint is also a cookie cutter. And you can have multiple cookies of the same cookie cutter shape. And that's the idea of objects. So when you define your own object, what you're doing is you're building the cookie cutter, you're building the blueprint, and then it's up to the programmer to instantiate or create cookies with that cookie cutter, or to create houses with that blueprint. And we call that to instantiate. Okay, and that's why we say it's an instance of the string class that contains different data, and that's why we use that term instance or to instantiate, because we're taking blueprints of an object that we've defined, and we've created multiple strings from that string class definition. Now, the string class is defined for you. You're going to be defining your own objects that are what we call user-defined objects. So when you define it, you're defining what the object holds, what the object is called. Is it a string class? Is it an integer class? Is it a double class or float class? Yes, in C# and Java, the int keywords, they're not really primitive data types. They're actually objects. You just don't really see that part of it. And then you can, define your own object and then create different instances of it. So let's go into actually building a simple class called rectangle. And we're going to talk about a few things as we progress through that. I'm going to go ahead and go into NetBeans for this part. This is our demo time for some fun. And then we're going to come back to PowerPoint after we actually build it. So I've just started up a default project here in NetBeans, and I'm not going to create a different package. I'm going to keep the same chapter or package chapter 3. Namespace is the other word for it. I'm going to keep the same package. So I'm actually going to go over here and in my chapter 3, and I'm going to right click here in packages, and I'm going to say new Java class, and I'm going to call this one rectangle. Now, rectangle is a pretty common class name, so I'm going to go preface this with just like M for my rectangle. So this is a definition of my rectangle that I'm creating. Rectangles is a pretty common class name. I'm pretty sure there is a rectangle class, but it should be fine because it's going to be protected by a different package name. So it doesn't really matter. You can call it rectangle. As long as we have it in the chapter 3 package, then it's not going to clash with anything else. Okay, so I'm going to go ahead and hit finish there. And then we've got our class declaration. Now notice since I right clicked on it underneath that chapter 3 over here and said add, it automatically came in with the package chapter 3. Now I'm going to go ahead and zoom in here, and we're going to look at the class rectangle. And what we want to do is we want some data to exist. This is the rectangle definition, guys. This is not an instance of mRectangle. We're defining our own object here. So we're defining what the object is, what it has, what it holds. And I call this definition code. So what I'll do now is I will declare some variables that we're going to use to represent a rectangle. And rectangles are pretty much represented with a length and a width. So what I'm going to do here is I'm going to say that we're going to have a special protected mode that we call private versus public. So right here I'm going to say we're going to have private rectangle, and what it is it's going to be not rectangle, excuse me, private int. No, let's make that float. Private float length, and then that's a property. Private float width. You're like, well, Mr. B, what's this private public thing? And so we're going to talk about that actually right now. And whenever you're authoring objects, I'm going to have you guys do several different characteristics of it. We may spend just the rest of our time here on just making a perfect object and not get too much further in the PowerPoint. We'll see how it goes and how much time we use up. What I want to show you is I want to show you the difference between public and private. So this just defines a class called mRectangle, and since it's inside the same package, we don't need to have any special use when we go to use or create a rectangle or create some cookies from our cookie cutter. This is our cookie cutter or our blueprint that blueprints what this object's going to have. And what we said is the object is going to have two numbers in it, length and width. They're floating point numbers. So let's go ahead and go back to our main here. And what I want to do is I want to instantiate the class now. So I'm going to go into here and I'm going to say, okay, Mr. Rectangle that I've defined, I now want to create one of you. This is just like saying I want a string called hello, and then signing it equal to whatever you want your string to be. And in this case, I think I need to use a capital S there, probably. Yeah. Okay. So in this case, our data type that we've declared and defined ourselves is mRectangle. That's what we got here when we declared class mRectangle. So I'm going to go ahead and I'm going to go into this part and I'm going to say, okay, I want an mRectangle, just like you're saying I want a string, or just like you're saying you want an integer called I equals to 3. It's the same thing. So it's the data type, the name we want to give the data type, and then we initialize it with something. With objects, not always will you initialize it. So I want an mRectangle data type or cookie from the mRectangle cookie cutter, and I want to call it rect A. Rect A. Okay, that's fine. We'll have a rect B and a rect C. Okay, so rect A is now instantiated. I've said I want the data type mRectangle, and I've given it a name. Just like string hello has been instantiated. Now we're getting a little underlined because we haven't really used them. But what I can do is we can modify this this a little bit, and we can make this public here, and let's leave this one private. Okay, and now I have the name rectangle called rect A, and if I want to assign some data that we have inside of our nice little rectangle, I would use the name of the object and use the member access operator. And you can see right there that a lot of this junk is stuff that comes default for every object that you declare on your own in Java. But you see here that we have length. But you also notice here that we don't have width. So I can say length is equal to 2. There. Now, the only reason why this is allowed to happen and why we can do it is because length is essentially a public, it's a public variable. So we go back to our rectangle and we see that length is public. So we can only have access to this private within scope of the rectangle itself. The scope being if it's private, then you can only change a private field between this first brace and this closing brace, or in the scope of the rectangle. Since we are creating the rectangle out here, we are outside the scope of rectangle. So we can only have access to public members outside of the scope of the rectangle, meaning that if it's private, then that means we can only access that private data type called width inside of rectangle itself, inside of these two braces. If we make it public, then that means that we're giving access to it from somebody that is using our object, us, and they can access that variable and modify and mess with it from outside of the scope. So essentially, we're giving access to it. And there's a reason why we want to protect access, and that's because we should be building functions that access that data so that we can look at that data and make decisions. Because, hey, what if we try to set a length to -100? Well, I don't know. Our rectangles actually have a length of negative? I thought length for a rectangle has to be a positive value. Wouldn't that mean it would be a non-rectangle because it, duh, or, that sort of idea here is, you would, if you are building an object for somebody to use, even yourself, you want to build that object as easy to use, but here's the most important thing about that object. It's your job to protect the data inside of it. And that's why we have the access or mutators that we're going to be talking about here shortly. So we don't want to allow this. Now we could open this up and the definition, and I can make this private or public down here, and you would see that back here outside of scope, we would now be able to pull up, and you see what is there now? Okay, so we were hiding that from ourselves. Which is what you want to do. You do not want to give the user of your object, the end user of your object, somebody that's using it outside of scope, access to the data inside. It's your job to protect that. You can't allow it. And so that's one of the tenets of abstract data types is information hiding, information protection. That's why we have what's called getters, setters, mutators. The setters is what we also call a mutator, and we're if we get back to the PowerPoint, we'll start talking about that. But let's go ahead and continue on with this idea. Is hey, we have a rectangle. We should not be having public. It must be private. This must be private. We should not allow anybody to mess with our data inside of rectangle. Which means that we have to give access somehow, so that we can allow the user of our rectangle class to change the length of the rectangle or change the width of the rectangle. But it has to be something that is allowed with a little bit of some brains involved. It needs to have an if statement. And I'm going to put an if statement, even though we haven't talked about if statements yet. Which is one reason why I don't really like talking about objects yet right off the bat. But we have to just even talk about getters and setters. So essentially what we want is we want a series of public functions. I'm not going to build them for width. I'm just building them for length. But you would have the same exact functions for width also. So a well-built object will have accessors and getters and setters for your private data fields. So it would be get length would be a function that we're building, and this is going to be a function that returns a floating point value, and it's a function that's public. And what we do is we just return length, and what that does is it gives us public access to the number that we're returning. And then we have another function that gives us access so that we can set the length. And I'm going to call this set length. But in here I'm going to pass a value, float L, for the new length. And you can just give it the same name, but you don't really kind of want to, because you got to differentiate the length that you've built in your object to the length that you have here. So I'm just going to say p length, and we'll talk about the this or me statement later. And so what we're going to do is when we set length, we're going to pass in a number, and we're to say, hey, is that number that you passed in p length? Is it less? Is it greater than 0? Is it greater than -1? If it is, then we're going to allow the length inside of our object to be changed. So we'll say that length is equal to the passed in length that we want to allow somebody to change. Okay, so look, how does this all kind of come together? And we're going to look at that here in a little bit. Notice that these have the public preface to them. And so that means that we're going to be able to, Why do you not like me down here? Oh. Yeah, this needs to be void. Excuse me. That's not get length. That's set length. So we're changing it. So notice that it has public in front of it. So what this is this is a getter. It returns the length that is being privately hidden by your object. This is what we call the setter. It is setting the length that is privately being protected inside your object. And you notice the whole reason for us protecting it is so that we can surround it with an if statement and only allow it to be changed if the person who's using our object sent in a value that actually makes sense. Because it could be something that accesses hardware, and if you set it to -1, it would blow up the hardware, whatever, or crash the plane or something like that. So that's the idea of information hiding and only using getters and setters. This is also what we call a mutator. Now, when we go back to using the object right here, we can now bring up length. This will no longer work anymore because we made it private. So if I do a rect A dot, you see length and width are gone. But what is here? Get length and set length. They are our gateway into the privately held information inside the object. And so when I do a set length, that means that I'm assigning 34 to the length of that object. And essentially, that's the whole reason for all this stuff to, for getters to setters to work in the first place, is to have that information hiding to protect the data inside the object, because that's the whole reason for the object to exist. We're building a box called mRectangle, and that box, inside that box is length and width. It's our job to protect length and width and not let somebody be stupid with it. Okay, so I'm going to go ahead and debug this, and we're going to walk through each of these lines and see kind of what's going on. It might not like me. We might have to move on. Yeah, let's move on. So here's what would happen if we had things working. I think I probably forgot something. But essentially, when we run this set length, what it's doing is it's changing. This is what we call the setter. And when it runs, it is allowing access to our length, and we're changing the length inside of what we pass to the set length function. I'll debug some of this here later. Actually, you know what? Let's take a break. I'm going to play around with this and figure out why it's being a stinker, and then I'm going to come back and we'll continue on. And then, of course, we're going to get back to some of those PowerPoints. I'll be right back. Okay, yeah, well, I quickly figured out what I was doing wrong right off the bat. Yeah, I didn't put the constructor in. So that takes us, I'm going to go ahead and demonstrate the getters and setters here shortly. But before we begin, we got to talk about the constructor. The constructor is a very special function that is part of an object, and it's a function that automatically runs. You don't have to call this function. It's runtime code that's part of your object definition that is automatically called when you create an instance of it. So that means that when we create an instance of the object right here, line 21.
Playing from R2.
Please ignore Alexa. So the rectangle, we were saying I want an M rectangle called rect A. That is where we instantiate the rectangle called rect A. When that line runs, one important aspect of all objects that you need is the constructor, and that is runtime that is designed so that you can initialize your variables or do any kind of initialization that's needed for that rectangle. So a constructor is automatically called when this line runs, line 21, and it is for this purpose. So what I'm going to do is and it has to be public, It has to be public. It's a public function. So I'm going to go ahead and declare it. Now, when you declare a constructor, you're saying I want a public function, and you use the same name as your definition name. It's the same name up here that you use. So that's what declares your construction object. And you can actually have more than one constructor, but they have to be different in some ways. But this is the reason why we have a constructor. We say we want length equals to 0 and width equal to 0. So that the goal of that constructor is just essentially to initialize those values. So what happens when this constructor is automatically called is length is set to 0 and width is set to 0. Now we can also overload it, but that's a discussion that we'll get to later. This is just we can talk about overloaded constructors at another time. So now when we go back to our code that we're writing, we won't have an error when I go up here to rebuild it. So I'm going to go ahead and do a clean. It looks like set length. It doesn't like set length right now. Maybe some other things, but we may be, you know what? Let's see. It does not like set length for some reason. All right. Yeah, I'm going to have to probably come back, guys, and see what's going on with this little critter, and then we'll continue on with our discussion. The constructor has been built so that it initializes, and then we'll see why it doesn't like this line of code yet. So we're almost there. All right, the last bit. You probably don't need the constructor, but I did forget this bit. When we instantiate it, because it's a reference, I kind of forgot that we got to actually say equals new here. We say that rect A equals a new rectangle, M rectangle. Now that's an important bit of code because this just declares it, but this just declares the pointer, the reference. This actually makes it point. So let's actually take a little time on this because this is an interesting little part that I kind of breezed by and through. Let's go back to our example here. So when I declare the rectangle called rect A, all that's doing is setting up this part right here, this guy right here. It just sets up the 4-byte pointer. It's not until I actually say equals new that it creates the actual dude here. Actually, you know what? Let's even be a little bit more verbose with this. Let's go here to a new whiteboard. I think I can just do clear canvas. Good. Okay. All right. Let's go back to this code. And let's just talk about here, because you don't have to do it. You don't have to say new right off the bat. You can just declare it initially. But this line of code, all it's doing is setting up the reference. So that is doing this part. Setting up the 4-byte pointer called rect A. And let's say that it exists from 2000 to 2003 in your RAM. It's 4 bytes. Pointers are always 4 bytes. Then that's all it's doing. The pointer is pointing nowhere, essentially. So the pointer is located in RAM at address 2000 to 2003, 4 bytes, but it's not pointing anywhere. So we basically created a 4-byte reference called rect A. We haven't actually assigned it to a new rectangle. So then we go back to this bit of code and we say equals new rectangle. That's when that equals new rectangle is when we're actually creating that rectangle. So that equals new, what is happening is a rectangle is being created in RAM. And let's say that the rectangle is 8 bytes. 8 bytes. And so that rectangle will be from address 3000 to 3007. And in it we have our length, and we have our width, we have our getters and our setters and whatnot. So as soon as that rectangle is instantiated, that's when we assign the address 3000 to the reference. And it now points to that rectangle that is actually in RAM at that memory location. And that's why we call them references. So we needed that little important bit to get everything working. So now we've actually properly instantiated our code, or our object right there. We've created the new rectangle. We've assigned it to our reference type. Now we can run the setLength function. So I'm going to set a little breakpoint here that runs this. Now what I'm going to do here is I'm going to do a step into. And what it's going to do is when this rectangle is instantiated, it's going to run, hopefully the debugger will actually run the constructor. So I'm going to go up here to the debug tab, and I'm going to say debug project. Okay, now we stopped at this line, and this line has not run yet. And what I want to do is I don't want to do a step over. I can do a step over, and it'll just go down to the next line. What I want to do is I want to see what's going on behind the scenes of this line. So I want to run this line and step into it and see what's going on behind the scenes. So I'm going to do a step into here, F7. I'm just clicking up here in the step into spot. My little cursor's up there. And there it goes. So that constructor gets called, and it does all the steps in that constructor, such as setting length to 0, width to 0, and then it moves on. And then we can go down here, and then this function runs the set length. We're passing 34. So I'm going to do another step into here, and I'm going to step into there, and we're going to go, and we are now, our green is now running here. The P length that we passed it is 34. We can even see down here in our variables that P length right there is 34.0. Length, we know, is 0 because we assigned it 0. And we even see in the this here field, and we go to length, this length, and you see it's 0.0. So we're essentially saying, hey, did the person that wants to set the length of our object send a good number, something that's less than 0 or more than 0, 0 or more? And if they did, then we allow that change of data to happen. We allow the length to be assigned to the value 34. And then that's, us driving our object. So what we've done here is we've defined the object mRectangle. We defined the constructor that initializes the data inside of that object, length equals 0, width equals 0. Then, and this function runs when the object is instantiated, which happens on this line right here, line 21. Then we use the setter set length to assign the length inside the object to 34. And incidentally, that's what this is. So when we are working with this, why should we call that P length? Let's call it length, and let's differentiate between the length that we call here as length to the length that's actually in our object by using this. So what we want is we want to refer to the object length. This dot length is equal to the past in length that we're just calling length. And that way we can take the length name that is locally created here that is not going to be confused with the length that's for our object, because that we have to call this.length, meaning the object itself, this.length. It's kind of like you're inside the object. The object does not know it's called rect_a. It does not know it's rect_a.length. So we refer to the object as a whole inside the object with the preface of this.length. Okay, guys, that's objects kind of 101. So here's the deal. This is a properly built object. Every object should have a constructor. Every object should have data that you're hiding inside. Every object should have a get function. Every object should have a mutator or a set function. Or not every object, but I mean every data type in the object. So for width, we should have a get width and a set width. So for every data type inside of our object, we need to have a getter or setter. Unless we are making it so that the this property length is read-only, and if it's read-only, then we would only allow people to get that, and we would just take this out. And then we wouldn't give anybody using our library access to be able to change the length. And that would be a read-only property for mutators. Okay, so let's go ahead and go back to our PowerPoint now that we've had the objects authoring 101, the beginning. Don't worry, if you're kind of like a little bit, oh, what's all these functions? We haven't even talked about functions yet. We haven't even talked about if statements yet. Don't worry, I'm trying to give you a little bit of background knowledge of everything that is being described in the PowerPoints. You're going to be learning these things and working with them as we go. So back to here, we just wrote a class called rectangle. We've put a length and a width in it. We should have a set length, a set width, a get length, a get width. And then we get into the idea of what is this area thing, this get area. Well, that would be a function where we would want to process the area from the length and the width. So essentially, when we are working with objects and we want to design objects, we use a special kind of diagram. And the diagram, we call it a UML diagram. And in that UML diagram, you create a box and you put the name of the object, the attributes, that means the data types, the doubles, the floats, the primitive data types are in the object. And then the functions that access those attributes or work with those attributes go in the UML diagram as well. So to get an example, here is our rectangle. So, you notice that I didn't put the set width and the get width in there. That's fine. You guys can play with that and do that on your own if you wish. But we did do the set length and the get length. The set length is the mutator or the setter, and then the get length is the getter that gets the information or the length data type. And so another function that we would want to have in there is called get area. So what we would want to do with that is use the length and the width to calculate and return the area that represents. When we working with area, since the length and the width can be changed, we don't really want the area to be its own variable. We don't want an area variable inside of here. We want to calculate the area from the length and the width. I believe they call those, well, that's coming up here pretty soon. So we'd also need to keep track of our access modifiers, public versus private and protected. We've just talked about public and private today. Protected, you'll read about a little bit more. It's more of something you use with an inheritance hierarchy. We won't go into it too much. Actually, they do have it. Yeah, no, we're not going to talk about protected. You guys aren't there yet. We haven't really gotten into inheritance yet. So public and private we've talked about as your access modifiers, and we've created them, and we call that encapsulation or information hiding, Protecting that data, that's also data abstraction, and encapsulation is the key terms that we use. So data abstraction and encapsulation is one of the main tenets of objects. So when we design a class, we need to have all those parts of an object. We need to have the name of the object, the data that the object holds, and then the methods or the functions that work upon that data. And not only that, but what is public and private to the person using our object. Somebody that's using our object in main will have access to public methods and public functions, but they will not have access to private methods or private functions. So that's going to need to be part of your UML diagram. So the proper way of doing a UML diagram is I'm going to move ahead right here. This is the proper way of doing UML diagram. You notice that we have a negative there for width and a negative for length because we declare those as private. We notice also that we have a public set width, set length, get length, get area. Those are for the public functions that we'll have in our object. And you denote in your class diagram, your UML diagram, the data, its access type with the minus, they're private, and then the functions that we have. One thing that's not in here is the constructor of the rectangle, but we have you would put the constructor with a plus in here also. We would also want to probably have a better another constructor for overloading. We'll get into that later. Well, let's go back to this stale data part in our UML. The stale data is talking about how when we use the area calculation, we should not have a property or data type inside of our object called area, because area is calculated from length and width, and length and width can be changed at any time through the lifetime of or the instantiation of our object. So essentially what we're going to do here is we're going to make a change to our object, and we're going to go up here, and you know what? Yeah, we're going to keep it private. We're going to say private. Oh, okay, it looks like I'm not doing very good on the keyboard. I'm going to say private float area, and I'm going to also assign area equal to 0 to begin with in our default constructor. Then down here, I'm going to build a function called getArea. Now, since we're allowed to set the length and set the width, remember I did not put the setters or getters for width in here. You guys can, that's in the PowerPoints or whatever, you can add them yourself. But what I'm going to do is I'm going to build the area function, and the goal of the area function is to process the area from the length and the width. So we don't really want this. We don't really want that. We don't want area in there because this is something that has to be calculated on the fly because we allow the length and the width to be changed. So this is what we call stale data, because it could be stale. So what happens when we assign area equal to the length and the width? Then somebody uses the object to change the length. Then that means that we'd have to recalculate the area here in the set length. And so since you would have to recalculate the area here, we call that stale. So instead of doing this, what we would do is we would just build a function in here that's public that just says get area. And it's going to be a floating return type, get area. And what it's going to do, and we can do a local variable called area here, or we can just return the length times the width. To get our area. And then what will happen is it'll take length times the width. It'll return that answer back to the calling area, and we would have that. So we don't want this. That's stale data. Okay, so we got our get area function. Now let's play with that. Let's do something else. You know what? Since width is going to be defaulted, let's default the width, length, and the width to 1. I would actually prefer that to be 0, but we haven't done an overloaded constructor yet. So now let's go ahead and run this baby and test it from main by doing a system.out.print rectangle a dot get area, and that function is going to return the area as a temporary variable that'll then print to the screen. So in this case, since we set length to 34, our output should be 34. Okay, so 34.0 is our output for get area. All right, the last thing I want to do is I want to build a constructor that's overloaded that we can actually use instead of the default where it's assigning it to 1. We can pass the width and the length. And what you can do is you can have multiple constructors. This will be the second constructor that we can use instead of the initial constructor. And what we'll do is we'll pass a local called length and a local called width. And we will differentiate it from this dot width. Notice how when I say this dot width, it lights up this guy and this guy, but this guy I light up and it's not the same. So this dot width means the width inside the object, meaning the object this, because we're inside of it. And then we say it's equal to width, and then we'll say this dot length equals to the length that we pass in. Okay, now let's go ahead and run that in constructor. And what I'm going to do is I'm going to, instead of using the default constructor, I'm going to use the overloaded constructor that I just created, and I'm going to pass in 4 and then 8 as length and width. And I'm going to go ahead and set the breakpoint here so we can do a step into. I'm going to run this and debug, and when it stops here, I'm going to do a step into. Okay, it's going to go in the function. Length comes in as 4.0. Width comes in as 8.0. We assign the width in the object to the width passed in, and then we assign the width and the length in the object to the length passed in. Then we go back to the next line. We do a set length of 34. Okay, that means we changed the length. But now I'm going to do a step into here so it calculates, so we can look at what get area is doing. So I'm going to go up here and I'm going to do a step into. Does it not like me today? It does not like me today. I wonder because it might have gotten confused with the print statement. There we go. Oh, it looks like it went too far into it. Okay. To the get area function. Let's go ahead and go back. Let's see if we can't invoke that get area call. You know, it's going to be 34 times 8 is what it's going to be, because the length is 34, the width is 8. So it's going to be that big number. I don't think it's going to allow us to step into it. Let's see, because maybe NetBeans Debugger is not as good as some others. No, it doesn't really like it. Okay, well, we're going to cheat. We're going to do it this way. I'm going to create a float called A. I'm going to assign it equal to rectangle A dot get area. And then we're going to print float A instead. And that way we can do a step into and see what get area is actually doing. because it just doesn't like that print function. It's trying to step into the print function instead of the get area. So now I'm going to do a step into the get area. Boom, it works. We return length, which is 34. And we look down here to the this, and we look at this length, and we got 34. Then we look at this width, we got 8. We return 34 times 8. And what's going to be printing, A is what is going to be printing, and A has the value 272.0. All right. Now, this is the cookie cutter called M rectangle, because now we can have more than one rectangle. We can have a rectangle called C. We can have a rectangle called rect D. And all these rectangles can have different values, and we can, hey, if we were doing a 2D game programming, we could draw them on the screen even with specific colors. We can add a color data type inside of the rectangle object so that we could draw it on the screen with a specific color. Now, I don't really get into that too much with you guys until like I think it's 142. CS 142, where we do some 2D fun. So, okay, that is giving you kind of a quick brush on a lot of what it's talking about here behind the scenes with demonstration. It talks to you about how to do a proper UML diagram. Let's see, and sometimes it's better to start with a UML diagram, guys. Really, start with your, what is needed for this class, and then fill it in with the information that's needed. So as you see, we could have just skipped right ahead and grabbed all of this and just used it. They did do a few things that I don't like set length. They didn't put an if statement there. That's bad. That's not the way you want to do things. Set width, they did not put an if statement there. You should be checking for errors on whether you should allow the width to be set. So we are then, I built the driver program for this object as we progressed. So, and we've demoed it, and we've been talking about it and debugging it. We'll play around with it some more, guys, and play around with that step into. That's helpful for you to really understand what's going on, what's happening, because there's no magic in programming. Everything, it's hard work, and you want to know what's happening so that you don't do that stupid guess and check method of programming. Let's just print it out for debugging. No, step over, step into. Come on. All right, guys, this pass by value, I'm going to we already covered constructors, but we are really getting into a little bit too much into, we spent enough time. You guys can get the rest from reading in your book and exploring on your own and with your study partners. Thank you very much. Have a good one.